Hi, welcome to our workshop today. My name is Carl Youngblood. I'm a senior solutions architect specializing in blockchain at AWS, and I work closely with the Amazon Managed Blockchain Service. Today, we're going to be going through a supply chain use case. We'll be building a decentralized application, or DApp, that consists of a two-member consortium. One of the members is the retailer, which is responsible for labeling and selling products to consumers, and the other member is the supplier, who's responsible for manufacturing these products, inspecting the products, and shipping them off to the retailer. So in this use case, a product is going through many different phases as it moves from the point of manufacture all the way to the point of sale. And in many multi-party workflows like this, it's important for all the different actors, all the different organizations that are involved in this process to have direct access to the data and to see what's happening with the data and be able to respond to situations more quickly. And this is where blockchain can be really helpful, especially in these use cases that involve several organizations needing to collaborate together closely, because each member of the blockchain can independently verify that the business logic is being followed properly, and they can verify the state of the data cryptographically. So blockchain can really help in these kinds of situations. Let's get started. So the workshop that we'll be working through today can be found at the URL that you see at the bottom of my screen. And this interface is all available on the web, and you can advance back and forth in this using your right and left arrow keys. Now, in this workshop, it will require two different AWS accounts, each one representing a different member of the consortium. So what I've done is I've actually prepared two different accounts and loaded them up in two separate browser instances. You can do this using the persona feature of Firefox or the people feature of Chrome. You could also do this by opening up a regular browser window for one of the accounts, or opening up a cognito or an incognito window or a private window for the other account. So back to our workshop, let's take a look at what our first step is. So one of the things I wanted to mention briefly is that the philosophy I took as I built this workshop is that every part of the solution that's required to make this work should be visible to the learner. So as you go through the workshop, you'll see sections of code that are required to make the solution work. And this code can be easily copied by clicking this icon in the top right corner of each code snippet. In the process of teaching many workshops, my colleagues and I have observed that one of the common ways of getting stuck or slowing down is that users are editing text, and that's an error-prone process. So what we've done is we've tried to make it so that you have to type very little to complete this workshop. But we present the source code to you so that you can see and study it if you would like to, so you know where you can look for more information. It's all there in front of you. So watch your AWS region carefully as well as you go through this. Amazon Managed Blockchain is not available in all regions, so you want to keep an eye on it. We'll be working on US East 1, but if you're using another region, just make sure that you're consistent throughout and put all your resources in the same region. So with that, let's move on to the first step. This is part of our prerequisites. We need to set up a Cloud9 environment. So Cloud9 is an integrated development environment, or IDE, that is very handy because all of your cloud resources are easily accessible. It's running just on a conventional EC2 instance. And it also has the convenient feature that it will automatically shut down after a configurable number of minutes of no use. And so this greatly reduces the cost of the solution, and you only are paying for the time that you're actually using it. So let's go over to our management console. One of the things that I want to also mention is that some of these steps that we'll be doing will be performed by both members of the consortium. That's the case for most of them. And when that's the case, I will have an overlay that indicates that this is both the retailer and the supplier who should be doing that. But some steps will only be done by the retailer, and other steps will only be done by the supplier. So just keep that in mind as we go through this. So this step will be done by both members. Let's go ahead and click Services at the top of our AWS Management Console and go to Cloud9. And we'll create an environment. We'll give it a name. And we just want to change the instance type to be something slightly larger, t3.medium. Keep everything else the same. We'll go to the next step, and we'll confirm that and click Create Environment. And this will just take a moment to start up. You'll notice that I'm skipping over some of the delays required to deploy infrastructure in the interest of time. So you won't be able to follow along with me in real time as I go through this. But you can consult this video and hopefully learn a lot from it for when you go about following the workshop on your own. So I've cleaned out the welcome screen, and I'm now at a clean terminal where I can paste in some new commands. And one of the commands that I need to execute is here at the bottom of this page. And this will just install the AWS command line interface. It will upgrade it to the latest version so that it is aware of all of the managed blockchain commands that we'll be executing in the course of this workshop. One other thing I should mention is that your Cloud9 IDE may come up in dark mode. Don't be alarmed by that. I prefer the high contrast classic mode, but it's just the same thing if you're in dark mode. So for our next step, we'll be deploying our actual blockchain network. This network will be hosted inside of a VPC that is managed for you by AWS. And you can see here an architectural diagram of the two members of the consortium. There are several components that make up a Hyperledger Fabric blockchain. And one of them is the ordering service, which makes sure that all the transactions are applied in a deterministic order so that the state of all the peer nodes in the entire network is consistent. Another important part of each member is the certificate authority that's used to identify the different clients and servers that the member has, and the peer nodes, which actually store the state of the blockchain and also simulate the transactions that are submitted to the blockchain to make sure that they follow the appropriate business logic. So we'll go to the Amazon Managed Blockchain console by clicking Services at the top of our AWS Management Console and typing blockchain and clicking on the result. And we're going to create the network for the retailer. We're going to leave most of this the same. We'll call it supply chain. The name for the first member is going to be retailer. The admin will be RT-admin, and we'll use a standard password for simplicity's sake, but of course use a more secure password when you do this in production. And I should just add that this step is performed by the retailer only. Now, one other thing we're going to be doing is we'll be skipping over the deployment time. Normally it takes about 20 minutes to deploy all this infrastructure, but in the interest of time, we'll skip over that and move along. So the first member of our network is finished deploying, and we're going to go on to that member, and we're going to provision peer nodes for the member. We'll create two peer nodes, and we'll enable chain code logs on them so that we could debug our chain code if we'd like to. And we'll enable them in separate availability zones so that in the case of an outage in one availability zone, another one will still be available. For the next phase, we'll be inviting the supplier to join the network as the second member. For the next step, We will be inviting the supplier to join the blockchain network. To do this, you'll need the supplier's AWS account ID handy. I happen to have that already ready on my clipboard. You'll just want to follow this syntax and substitute the actual numbers where the account ID should be. And we'll do that in our retailer Cloud9 terminal. And then we'll paste these commands to invite the supplier to join the network using the AWS command line interface, or CLI. And if the command executed successfully, we should see output like this, showing a proposal ID, and we do. The retailer now needs to vote on that proposal to approve it. We'll paste this command to do that. And that proposal should now be approved, and we can double check that by running this command to see a list of the proposals. And we see that there is one proposal and its status is approved. For the final phase of this first module, we will accept the invitation as the supplier. So I will be doing this in the supplier's Cloud9 environment. We're first going to go to the Cloud9 environment and right-click here and create a new file. And we're going to call this file accept-invite.yaml. We'll double-click on it so that we can edit it. And we'll paste the contents of this CloudFormation template into the file. Remember to save it using Command S. We'll then deploy this template using this command. This will take a few minutes to complete, like the first member as well. One thing you can do if you want to follow along with the progress of that CloudFormation template is to go over to the CloudFormation console in your AWS Management Console and watch the progress of it as it goes. CloudFormation is a great way to deploy resources in a programmatic way, following a pattern we call infrastructure as code. So now we have our supplier has joined the blockchain network, and we're all set to continue. That's the end of Module 1. Congratulations, you've deployed your blockchain network, and we'll now move on to Module 2. For the next module, we'll be installing the Fabric client on each member of the consortium. This is an EC2 instance that will be used to configure and deploy smart contracts that will be used in our blockchain application. One of the first steps is to create a security group. To do this, we will go to EC2 in the Management Console, go down to Security Groups, create Security Group, and we'll call it HF Client and Endpoint, and give it a description. We'll delete the inbound and outbound rules for now. First create it. And then we'll edit the inbound rules. We want to add a rule that allows all traffic from HF client and endpoint, which is the same security group we just created. So this just allows traffic to flow between any devices that are in this security group. We'll also add an outbound rule that's the same. We'll also create another security group. And we'll call this one HF Client SSH. And this will be used to allow us to connect via secure shell with the Fabric client from our Cloud9 terminal. For this rule, for this security group, we'd like to make a single inbound rule that allows SSH from anywhere, and an outbound rule that allows all traffic to go out, just like it's at its default setting now. We'll create that security group. Next, we'll create a VPC endpoint that our client will use to talk to our infrastructure in the blockchain network. So to do that, we'll click on Services, go to Blockchain again, and we'll click Create VPC Endpoint on our network. We want to place it in any of our subnets in the default VPC, and we want to select the security group we just created called HF Client and Endpoint. The next step is that we will create some identity access management policies that will be used by the Fabric client to manage the blockchain network. To do this, we'll first copy this JSON policy settings, and we will go to IAM in the management console, go to Policies, we'll create a policy, select the JSON tab, and we will paste this over that. And then here, we want to use the AWS account ID of the member we're working on, and replace all 4 instances of those numbers with the account ID for this account. We'll call this policy Amazon Managed Blockchain Control. And next, we're going to create a role. So we'll go into our left sidebar in IAM, and we will create a role. This role will belong to an EC2 instance because it's a service instance role. And now we're going to select the policy that we just created by typing in blockchain, selecting Amazon Managed Blockchain Control. And one other thing we're going to add here is administrator access. There are several things that our Fabric client's going to need to execute, and rather than creating 10 or 15 different policies, we will be creating an administrator policy and attaching it to this role. But as soon as we're done provisioning everything, we can remove that administrator policy and just leave the blockchain settings, the blockchain policy. Go ahead and hit Next, Next, and we will now call this role Service Linked Role for Amazon Managed Blockchain. And now we've created that role. Now it's time to create our client instance. We'll go over to EC2, click on Instances in the left sidebar. We'll launch an instance. We'll want to narrow down our search by typing this. It was at the top of the list, but sometimes the order of the list changes, so I like to always narrow it down. We'll select t3.medium as our instance type. And we want to leave these settings as is, except the IAM role, and we'll select that service linked role that we just created. We'll go ahead and leave storage as is. In our security group settings, we're going to select the 2 security groups that we created previously. And finally, we'll launch the instance. Now this time, we need to create a key pair for this instance so that we can connect to it. And we don't have an existing key pair, so we're going to create a new one, and we'll call it fabric client. We need to download that key pair before we're able to launch the instance. And we launch the instance. The next thing we want to do is go back to our Cloud9 environment, and we want to upload a file by clicking in File and Upload Local Files. And we're going to select the Fabric client file that we just created. If yours happens to have been renamed by your browser, just remove those extra characters and call it fabric-client.pem. And then we'll go back to our steps and we'll execute these two commands to move that key file into the right place. That'll be in our SSH folder where we can later use it to connect to our Fabric client instance. And one last thing we're going to do is we're going to go into our EC2 instance, and we're going to hover over the pencil in this newly created instance, click on it, and we're going to call this Fabric client. This will be used to infer the address of the EC2 instance so that we can connect to it more conveniently. We'll now take this command, paste it into our Cloud9 terminal, which will set up that convenient entry for us in the SSH config. And because of that, we can now SSH to our Fabric client instance by merely typing SSH space fabric-client, and we don't need to know its IP because that's already been pre-programmed into our SSH config. The first time you connect to it, you need to say yes there, and now we're connected to the EC2 instance. Next, we'll be installing some dependencies that are needed on the EC2 client instance. This first dependency will set up Docker for us. When that's done, we'll need to exit our Fabric client and reconnect to it just to update some user settings. And then we'll continue executing the installation of Docker Compose. Followed by some Golang utilities. Now in this step here, we need to have the AWS account IDs of both members of the consortium handy. And we want to paste those into our Cloud9 terminal, or apologies, the Fabric client. And then depending on which member we are working on at the moment, we'll export either the member name as retailer or as supplier. And we'll paste in these commands to update our bash profile so that it has several environment variables that will be needed to configure the blockchain settings. We'll then source the bash profile again to update the environment. And finally, we will echo out our environment to double check that the changes took place. So what we're looking for here is that every environment variable has some value and everything looks good. At this point, we should be able to test our VPC endpoint and see if we're able to connect to the member's CA. And we see that we did get a response back from the CA, so that looks like it's working well. Next, we're going to do some additional setup commands for our Docker environment. This will set up Docker Compose, which is used to execute the Fabric commands inside of a container. And we'll also download this repository, which has some sample chain code or smart contract code that we we'll be using to test our network to make sure it's functioning properly. Just finished pulling up Docker Compose. And now we'll download the root certificate for AMB, which is used to identify the different members of the blockchain. We can double check that certificate to see that we downloaded it successfully, and we see that the certificate does look like it's been parsed properly. Finally, we'll enroll the administrator for the Fabric client with this command, which generates some certificates that will be used for that member's administrator. We'll create a test channel on which we're going to be deploying our smart contracts just to see that they're functioning properly. And we will generate a configuration for the channel here. And finally, we'll use this command to create the channel. This command sometimes times out, and so we've designed it to keep looping until it succeeds. And this is the output we're looking for here, so that's good. Finally, this command will tell our peer to join the channel. And that succeeded. At this point, we can now install chain code on the channel. We're going to install some of that test chain code. Chain code is the term that we use for smart contracts in Hyperledger Fabric. So we installed that test chain code, and now we're going to instantiate this chain code. When you instantiate chain code, you're actually loading up a Docker environment in which your smart contracts will execute, sort of a pristine sandbox. So it takes just a little while to do that. After instantiating the chain code, we should be able to list the instantiated or installed chain codes. And we do see that there's one result there. That's good. Finally, we're going to invoke the chain code. This is where we actually alter the state of the blockchain. So we've, apologies, we're actually querying right now for the state of the blockchain to see that our initial parameters are there. And we do see that the value of A is what we set it to initially, which is 100. And now we're going to invoke chain code to modify the contents of A. So this decrements A by 10 and increments B by 10. So now if we look at A, we should see that A is equal to 90 instead of the 100 that it started out as. If we wanted to, we could also check the value of B and see that it was also incremented. It started out at 200 and now it's 210. So our chain code does appear to be working properly, and this sanity check has shown us that our network is installed correctly. So that is the end of Module 2, where we set up our Fabric client. Let's go on to Module 3. So for Module 3, we're going to be actually writing our own chain code that's more tailored to our supply chain use case. We'll be installing it on the peer node through the Fabric client, and we'll be creating worker identities for each member. We'll create 2 different identities for each member, 2 different certificates representing each member, and these will be used to enforce the permissions of the different actors in the supply chain and make sure that only those people who are supposed to be performing certain operations are allowed to. So this should also be executed on both the retailer and the supplier. And we'll begin by configuring our Cloud9 environment for development by pasting the following into our Cloud9 terminal. We'll want to exit out of the Fabric client if we haven't already done so. And then we will go ahead and paste this command into the Cloud9 terminal. And this will set up our Node.js environment. And then what we'll want to do is we will want to copy the contents of these files into some files in the chain code folder that have been created for us. The first one is package.json. We'll want to press Command S to save the contents of that file. And then we'll want to execute these commands to install the dependencies of our chain code. So we'll paste these into the Cloud9 terminal as well. Next, we'll actually be writing our chain code. This chain code here is called products.js, and it contains all of the logic for our supply chain. You'll notice that there's a state machine in this smart contract that enforces the state transitions from one state of the product to the next. We'll copy the contents of this chain code file and go into products.js and paste those contents in and save. And I encourage you to take a closer look at this code to see what it's doing. We're also going to be unit testing our chain code with this test file, products_test. So unit tests are a great way to make sure that if we update functionality, that the rest of the application is still working as expected. And now we can actually test out our chain code by running these tests that we've just created from our terminal. We'll go ahead and do that. And we should expect to see all the tests passing, and indeed, all 17 of our tests are passing. Now it's time to do some commands only on the retailer. So for this, we're going to connect to the retailer's Cloud9 environment, and then from there, connect to the Fabric client. Then we're going to be creating a bucket where various certificates and other files that are needed to be seen by both members of the consortium will be shared. And finally, we'll grant access to the supplier on this bucket so that it can put its resources here as well. So our next step is to create these member identities that will be used to represent the different workers who are working on different phases of the supply chain. So we'll have each member of the consortium execute these commands in their Fabric client. Next, we'll configure the main channel that both members of the consortium will share and put the chain code onto so that they can execute the chain code together. And this next step is performed by the retailer only. This is the process of creating the actual channel. So the retailer will bundle together various files that both members will need and send them to the bucket. Then it will create a channel configuration for this shared channel. And we'll double check to see that the file that it created is there. It does look like it's there. We'll then create the channel. That's the expected output, so the creation succeeded. And finally, we'll download the Genesis block of the channel. And the retailer will now join the channel. The next command is performed by the supplier. The supplier will download the certificates that it needs from the bucket. It will download the Genesis block of the channel, and it will join the channel. And that looks good. In this next phase, the retailer is going to do some work to package the chain code so that the other parties can have the same exact copy of the chain code and verify its integrity. So to do that, we're going to go back to the Cloud9 terminal, and we're going to substitute the contents of the package.json to remove all dependency declarations except for one dependency that's included on the Docker sandbox where the chain code will be running. This is important because the sandbox does not have access to the internet, so any dependencies declared there would be attempted to be downloaded and that would fail. So what we'll do is we'll bundle chain code without the dependency declaration so that it won't attempt to do the download. Next, we'll paste the following commands in to prepare the chain code and copy it into a certain place. we'll exit out of our Fabric client, paste these into our Cloud9 terminal, and then we'll connect back to the Fabric client to finish packaging the chain code. And these commands here will package the chain code and put it in the right place. So we've packaged the chain code. And now all members should install the chain code by running this command in their Fabric client. Next, we'll have the retailer instantiate the chain code. This only needs to happen once on one of the members. And as I mentioned, the instantiation process takes just a little bit of time because it's spinning up that sandbox. And finally, we're going to be testing the chain code by running some commands from the Fabric client that will simulate the actions of each of the different worker identities. So they'll basically be executing each of the commands to create a test product and move it all the way from manufacturer to final sale. So we're going to start out in the supplier to do this. I'm going to take the copy the first command and paste it into the Fabric client of the supplier. This first command sometimes takes a little bit longer, but the others tend to go faster after that. This is the command that creates the product, and that succeeded. We see that it returned the state of the product as manufactured and a history with a timestamp of when that occurred. Now we're going to do the next command, which is the inspection. That did update the state of the product. And finally, the worker is going to ship this off to the retailer. So those are the first three steps. And let's continue with the steps that the retailer will perform. Those should have been performed by the supplier, by the way. Sorry about that. Should have had the right overlay on. Those are the supplier's commands that we just performed. And now we'll switch over to the retailer to perform its commands. So we'll paste these commands into the Fabric client. And it first received the package, then labeled the package, and finally sells the package. And so we've taken that product all the way through the various states, performing those actions with different identities who are authorized to perform those actions. So with that, we are finished with Module 3. We'll then move on to Module 4. So blockchain is a bit of a learning curve for a lot of people. Getting used to the constraints of programming and chain code can be a bit challenging at first. And often what we would like to do is be able to communicate with our blockchains using more conventional paradigms. So in this module, we're going to be deploying an API that we can use to do a lot of our blockchain communication. So as you can see from this architectural diagram, we have our various worker identities. They'll be communicating with an appsync GraphQL API. That API will use a Cognito user pool to authenticate these workers and then call into a lambda function that will contain the worker's username that the lambda will then look up to retrieve the secrets of that user that constitute its identity. These secrets will be used to perform a blockchain command on that user's behalf in the lambda. The lambda will then return a result from the blockchain back to the API, which then returns it back to the caller of the API. So let's get started. The first thing we're going to do is store the worker's identity secrets in a place where Lambda can access them. It's in AWS Secrets Manager. So we'll paste these commands in to do that. Next, we'll create a role for our Lambda function. This should be performed from the Fabric client. We'll save the policy settings to a JSON file. And then we'll create a policy from that JSON file. Now our Lambda function needs to run in the same context as the Fabric client, so it'll need to be added to the VPC and placed in the security group that we created earlier. So this will create a VPC endpoint that the Lambda function will need to be able to communicate with Secrets Manager. When you place a Lambda within a VPC, it can lose access to certain AWS services that require internet access. So we're restoring that through a VPC endpoint. First, we're going to create what's called a Lambda layer, which is going to store several dependencies that the Lambda needs to be able to execute. And the nice thing about placing these in a layer as opposed to a part of your core Lambda function is that they can be treated and managed independently by the Lambda system outside of our Lambda function, which can improve performance and concurrency. And also, they make it a lot easier to work on your code in isolation rather than having a fairly large bundle alongside everything. And because they keep the size of your Lambda function smaller, it often allows you to then edit the Lambda within the management console as opposed to having to edit elsewhere and upload the Lambda as a bundle. So now that for this step, we're going to exit out of our Fabric client and we'll paste these commands into the Cloud9 terminal. And this will basically prepare a folder where we'll be copying the contents of the Lambda. So that Lambda layer is now published. And we see the expected output. And now we'll be writing the Lambda function itself. We'll want to copy these commands into our Cloud9 terminal to prepare the workspace for us just a bit. And we're going to paste the following code into our index.js file inside of this AMB supply chain connector, which is the name of the Lambda function. It's inside the source folder within there. And I'll paste that and save it. And then finally, we also need to paste a template for a connection profile that is used to tell our Lambda how to connect to our blockchain network. And finally, we have a script called publish Lambda that is used to put everything together and send it to the right place. It substitutes some of the entries in the connection profile with the correct values and then submits the Lambda function. So now that we've copied those into place, we can actually prep the workspace on our Fabric client by pasting this into our Cloud9 terminal. We can then copy the source files from our Cloud9 terminal to the Fabric client workspace and execute that publish script that will copy those to the right place and submit the Lambda function. So that Lambda function has been submitted and it's now in the process of finalizing the creation. We don't have a whole lot of time to go through it now, but I'd encourage you to go into the management console and take a look at the Lambda function that we just created. You'll see that there are interfaces where you can edit the code, test it out, change some environment variables, and adjust some configuration settings. It's quite powerful. Our next step is to create a Cognito user pool and populate it with the users in our workers who will be authenticating with the API so that they can perform their commands. We'll paste these commands into our Fabric client. And now it's time to create the appsync API. So for this, we will go to the appsync service. We will click Create API. We'll build from scratch here. We will call this API supply chain API, and we'll click create. Then our next thing to do will be to edit the schema and paste in this prepared schema that we have here, and then save that prepared schema. Just increase the size of my window just a bit. So the schema defines several functions, including the ability to create products, update products, query for products, and also subscribe to changes on those products. One of the first things we're going to need to do is attach the lambda resolver to this function. We'll click the attach button here to do that, and we need to first create the resolver here. So for this, the name of this resolver, we're going to call it AMB supply chain connector, and the data source type is going to be AWS Lambda function. We'll select our region, and we will select the Lambda function we just created. Leave the rest of the settings as is and hit create. Excellent, so we now have a data source. I'm going to go back to my schema by clicking over here on schema on the left sidebar, and I'm going to click attach again, and I now have the option of selecting that data source that we just created, and then I'll hit save. I'll go back to the schema, I'll attach it to the other mutation, and hit save. I'll go back to the schema again, and I'll attach it to the two queries that we have for both an individual product and a list of products, each time saving the resolver. And finally, this last one. What this has done is essentially made it so that this schema, in order to respond to queries, will need to go to the Lambda function and execute it and get the results. Now we'll want to update our API settings to use the Cognito pool that we created for authentication and authorization. So we'll go and do that now. We'll click on settings on the left sidebar, scroll down, and our default authorization mode will change to Amazon Cognito user pool. We'll select our region. We'll select the user pool that we created, and we'll change the default action to deny instead of allow. And then we'll scroll down and hit save. Very good. We'll now be able to test whether our query worked, whether our setup is working properly in this queries section. One of the first things we need to do is go find our app client ID in order to log in as a user to test it. So for that, we're going to go over to our Cognito user pool. We're going to click on App Clients in the left sidebar. We're going to copy this, go back to our appsync service, select the API, go to Queries, and we will log in and paste the client ID into that. And then we'll log in as one of the users in order to be able to perform a query. Its password should be password with a capital P, 123. So we're now logged in as that user, and we can execute a test query right here that will retrieve a product. Well, it'll retrieve the product we created earlier, and we'll hit play to execute that query and see how it goes. And very good, we got back the result that we expected. And with that, we're finished with Module 4, where we've created a GraphQL API that we can use to communicate with our blockchain contracts. Now it's time to build our front end. As you can see, we've got all the existing infrastructure from our other modules, and we're now going to be building the web UI front end that our workers will use to interact with the blockchain in a user-friendly way. This should be done on both accounts. We're going to first execute these commands in the Cloud9 terminal. And these will create the shell of our front-end web application and install some dependencies. Next, we'll want to install some additional dependencies that the web application will need. And then we'll want to generate some configuration files on the Fabric client. And finally, we'll return back to our Cloud9 terminal by exiting out of the Fabric client and copying the files that were generated on the Fabric client into our environment. We've also pre-filled some of the other files that we'll be filling in now in our web interface. So we'll open up the front-end folder and the source folder, and we'll now populate our React components from several source files. This first file, all products, generates a list of all the products and renders them in the web interface. The next one, all products with data, actually retrieves the data for the products from the appsync API and also receives updates when the data is modified. App.js contains a lot of the dependency declarations and inclusion of many different dependencies that the app needs to function. It also has the authentication info and bootstraps the configuration. Create product.js is called by the supplier worker to create new products. Index.css contains a lot of visual style declarations that make our site look the way it looks. Product.js contains logic about rendering an individual product listing. And states.js is used to track the various transitions that a product can go from. This component update product state is for modifying the state of a product and moving it along the supply chain. And with those 7 files in place, we should now be able to launch our application by going back to our Cloud9 terminal and pasting in these commands. We'll need to wait for the development server to fully load. And now that the development server is fully loaded, we can open up the web interface by clicking on Preview and then Preview Running Application. This will actually open our website in a secure environment where it can talk directly through a browser tunnel to our web service without having to expose that web service to the internet. So that's a convenient development feature provided by Cloud9. We've got the authentication of these various users hard-coded for convenience. So we'll first begin by signing in as the retailer worker, and we can see the interface that the retailer would see. We can already see that an existing product is in the listing, and we can see when it was manufactured, inspected, shipped, stocked, labeled, sold, etc. We can see that its current state is sold. We are now going to log into the supplier interface so that it can create some new products and we can move those along the supply chain. Another handy little feature in Cloud9 is that if you want a little more room for your web application, you can click that button in the corner and open it up into a full view. So I'm going to sign in as the supplier worker here. And I'm going to create a new product. We can see that the product appears in our table. It's assigned a serial number and its current state is set to manufactured. The next state is to be inspected, and for that we need to log in as the inspector. The inspector then has the ability to click inspect on this product, and as soon as it's done we should see that update. We see that inspected state is now updated. We will now sign out the inspector again and sign in the worker. And the worker is responsible for shipping inspected products, so we'll go ahead and take care of that step now. So it's now shipped, and the rest of this is going to be taken care of on the retailer side. So we are going to go over to the retailer. I'll bump this out as well. We are going to first, as the retailer worker, receive that product. We're then going to label the product. And finally, we'll log in as the seller and take care of the sale of the product. So we've now successfully taken a product in our web interface all the way from manufacturing to its final sale at the retail side of things. And with that, I want to conclude the workshop and say thank you for joining me on this workshop. I hope you've enjoyed the opportunity to learn a little bit about how to build a blockchain-based decentralized application. I'm really excited to see what you build on Amazon Managed Blockchain and look forward to answering any questions that you have. Thank you very much.